Hello, hello, kids. We are going to kind of have an extension right off of our previous lesson, writing an equation given a point and a slope. And today we are going to write an equation just given 2 points, but not a slope. That's not helpful. Actually, it's not so bad. So if you have already had lesson 5.2, I think I mentioned that this runs parallel to this lesson. So you'll notice that if you hold your notes side by side, they should look just the same. So there's 5.2, there's 5.1. That was on purpose. That was not a mistake. That's not a design flaw. I'm trying to set it up for you so you can kind of see how they all connect. So hopefully that makes it easier for you as we move forward. So some of this might be a little repetitive, but that's okay. That repetition helps us find our pattern and make sense for us. So similar to the last section, we are going to break down this whole, we're going to break down this question, this whole front side of a page, and then we are going to do it more succinctly on the back. Oh, and I keep forgetting my disclaimer. Of course, this is not going to be a perfect prize-winning, phenomenal, earth-shattering lesson. This is going to be the high points of the lesson that I teach in class, and hopefully a help for you from home. So there you go. So an equation of a line containing these points. So if you just want to visualize it, again, I'm all about knowing what you're actually doing. I don't want to just blindly stick some numbers in. So -1, -2, 3 and 6. So you're writing this equation, I don't know, like here-ish. I could be off, right? But I like to kind of visualize what I'm doing before I do it, just so I can kind of anticipate or predict, estimate what I'm going to end up with. Okay, so remember slope-intercept form, of course, is y equals mx plus b. Again, m is the slope, b is the intercept. Okay, hopefully you're like, Dr. Bones, we know this. Stop telling us. That's the point that I want you to get to. So if you're done with me, if I'm annoying you, then good. I've done my job. So our points are -1, -2, and 3, 6. That's all we have. Well, that is not helpful. It is, though, actually. What can I do with this? Well, I've given you a hint. Well, I could find slope with this. Can't write an equation yet, but couldn't I find slope? Yep. Remember x1, y1, x2. Did you think you were done with finding slope? Haha, you are not. So the slope of this line is m equals 6 minus -2. Be careful with those double negatives. Over 3. My brain froze for a second there. Okay, good. 6 minus -2. It's inversing 8 over 4, which is 2. Great. Okay. So now what? I have slope and I have 2 points. Well, remember in the previous section how we substituted information from the points into the equation? We used one of the points in the slope, but we could have done that same process with any points on that line. So we have been provided these 2 points, -1, 2, and 3, 6. We can use one or the other, and it doesn't really matter. Okay, so it doesn't matter which point you use. Which point you use. Okay, so what might be fun is if you were with other people, maybe one of you can write the equation using a slope of 2 with the first point, -1 and -2. So you would have, here's x and y. Y equals 2mx plus b, and you can do it that way. And maybe your friend can do, here's 3 and 6, x and y. So y equals mx plus b. Now, I use this to make a point that it doesn't matter. Doesn't matter which point you use. The point that I'm trying to make, that was a little redundant. What I'm trying to prove is it doesn't matter what point you use. Okay, so I'm just going to do both of them to show it doesn't matter what you use, you'll get the same intercept. Because both points are on the same line, right? So any point on that line is going to satisfy the equation. Remember again to write those values that you subbed in for the variables in parentheses. Again, that's really helpful moving forward. Now, knowing that, can you write an equation of that line? Oh, sorry, I didn't mean to move you. Hold still. Okay, yeah. So y equals, remember you drop the x and the y. Once you've used them to find the b, you don't need them anymore, right? Okay, so 2x. We got the 2 when we solved for our slope. 2x plus 0. Ah, wait. Do I write plus 0? No, I don't. So y equals just 2x. Don't need you. And again, yeah, we dropped the x and the y. Now, does that kind of jive with what we have? As a direct variation, that's total luck right there. So a slope of 2 over 1. Actually, it looks like a slope of 1, so maybe that's a little bit off. But anyway, it roughly matches what my prediction was. So that's comforting. Okay, halfway there. Okay, I don't want to keep reminding you, so I'm just going to say it once on the front of the page, and then I'm just going to talk through the end to kind of save on time. Please, at any of these points, just stop the video and see what you can do independently, and then restart the video. And then if you get a little hint and you think you can do a little bit more by yourself, then do that, because that independent thinking is really, really good for you. Also, though, if this goes too fast and you're starting to feel like it's a little out of control and you're just barely hanging in there, pause, go back a little bit. I know nobody loves just kicking back watching math videos, but rewatch so that you can, get what you're doing before you're too far gone. Okay? So that said, I'm not going to keep telling you to stop and rewatch and what are you going to do and blah, blah, blah. I'm just going to trust that you are going to do that, because you are the best professional in how you learn. So here we go. So we are going to write an equation of this line, including 14.2 and 10.6. So remember, this is x and y, x and y. Here's the first one. Here's the second one. Okay, so our slope isn't given to us, but we can find it. 6 minus 2 over 10 minus 14, because it's y2 minus y1 over x2 minus x1, right? 6 minus 2 is 4. 10 minus 14 is negative 4. Anything over itself is 1, and this is negative. Okay. And then x and y, I'm just going to use the first point. It doesn't matter. You could use the second point. So in my case, x is 14, y is 2. And so now I can use this in my equation. So y is 2 equals m is negative 1. Negative 1. Parentheses rounds be a good role model. X is 14. And we're solving for b. Sometimes that color coding helps people. If nothing else, it's pretty. Add 14. So 16 is b. And so now we can say, drum roll. That was a lame drum roll. Sorry. I need a snare drum for my lessons. I make things really cool. 2x plus 16. Nope. Do you see the mistake I made? Dr. Rones, you dummy. I pulled this. That was my slope. Aha. So you don't go back and re-record over my lessons or my errors because first of all, teachers make mistakes. Second of all, going back and looking again, that promotes critical thinking. So that's not such a bad thing. Errors in my world are just, what does Bob Ross say? Happy mistakes? I forget. Anyway, somehow we got Bob Ross in a math lesson. Anyway, so negative 1x is a little redundant. We just say negative x plus 16. All right, that's our equation. A little ode to Bob Ross, and we're going to move on. Okay. Whew. Next section. The equation of a line that includes this point and runs perpendicular to this guy. Remember perpendicular? Perpendicular lines intersect to make 4 right angles. This is going to be rough here. So here's a line we know, negative 1 and a slope of 3. I'm winging it here, guys. So this is the point, or this is the line that we do know. And this line runs, let's see, includes 0, 2 here, and it runs perpendicular. It's going to go about like this. Whew. And that's what we're going for. Okay. Do you remember what perpendicular lines have? They are the inverse. That has to do with the signs, like the plus minus. Reciprocal. Slope. That's when you flip the top and the bottom, right? Okay. So from this, we know the slope here was 3. So the inverse of 3 would be negative 3, and the inverse of 3 would be 1/3. So the slope is negative 1/3. Again, we flip the sign, positive to negative. If it had been negative, we'd make it positive, right? And the reciprocal of 3, because 3 as a fraction is 3 over 1, is 1/3. Okay, x and y. X is 0, y is 2. And now we just do the same thing we've been doing. So y 2 equals negative 1/3 of, what's the x again? 0. Ooh, that'll be easy. Plus b. 2 is, this is going to 0 out, right? I don't have to write it all out, but I'll be a good teacher and, show all the steps. You, of course, do not have to do all of that. I probably would have skipped those two. And then, so our equation is y equals negative 1/3 x plus 2. Does that match what our prediction was? Positive 2, a shallow slope. Yeah, so kind of proud that my prediction is so spot on. I mean, I get that I teach this stuff, but I'm kind of bad at stuff like that. So I'm just gonna publicly say, go me. I'm so humble. Okay, I just need to teach the lesson, runs, teach the lesson. Okay, so I would like for you to do the same thing. Now, of course, I folded this. I know what I'm doing, but if you are, struggling a little bit, keep that up so that you can see. So you can refer to the other one as an example, but I don't have all that much room here. So an equation of a line, that has 4 and 2, and runs perpendicular to y equals 4x plus 2. I don't even need this, do I? Right? But it tells you what the intercept is, but I don't need any part of that except for this, right? Okay, so my slope is the inverse of a positive 4 is a negative 4. The reciprocal of 4, which as a fraction is 4 over 1, is 1/4. X is 4, y is 2. And then hopefully this is starting to feel automatic for you. We've done it quite a few times, and we're just solving for b. 4/4, I hope you got that, is 1, but it's negative. So b is 3. And so you can write your equation, dun-dun-dun, y equals negative 1/4 x plus 3. It makes sense. Perpendicular lines, one's going to have a positive slope, one's going to have a negative slope. So this is positive, this is negative. Yeah, so great. All right, it's not easy stuff. It feels easy once you've done quite a few examples of it, but really you should be proud of yourself. This is getting pretty complex. Guys, I've made it quite a long ways so far this year. So, all right, here we go. Opportunities for learning. Who loves homework? This kid. All right, here we go. So, ouch. Here you are going to, again, write an equation in slope-intercept form. This is just like 5-2. So what they're trying to get you to do is to write an equation using these 2 points. So find the slope, and then use the slope in one of the points, solve for b, and then write an equation. You could do all that. And it would be cool to see how it all matches, and that's fine. If you want to do that once, go for it. But in my world, why do all that if you could just say y equals 1 over 1 is 1, 1x is just x, and there's your intercept. Like, you don't need to do all that, right? But wait, what if you get one like number 4? 4 is the one that might give you troubles. Okay, this one, you could of course say that your slope is up a half and write 2, or you could use, say, this point and this point and say 1 over 1, 2, 3, 4, and just do it from that way. Y equals 1/4 of an x minus 2, because they're numbering by 2's. Or in this case, you could be safe and use the 2 points, because sometimes when they don't put the points exactly through the grid lines, it could really be anything, right? I mean, it looks like a half, but what if it were like 3/7? It's really close to a half. It could be tricky, right? Okay, so I don't care how you do these 5, because I want to be practical. But maybe for this one, do it the long way. Solve for slope, and then solve for b, and see if you get the same thing, okay? Now, I get that I just gave you the answer, but, you know, we're chasing after learning, not homework questions, so. Yeah, okay. For this next section, write an equation in slope-intercept form of a line that passes through the points. You're just using the exact same process that we have been going through all the way through this point. So you could use your notes. I recommend that you write this on a separate piece of paper. I'm going to write an example here for you. Here's 7. It's hole punched for me. That's annoying. Okay. So you have x and y, x and y. Here's the first one. Here's the second one. So this would be -6 minus 0 over 3 minus 0, which is -6 over 3, which is the slope of -2. And then use one point or the other. I'm going to use the 0, 0, because that just makes my life easier. So instead of y equals mx plus b, y is 0 equals mx plus b. 0 equals 0 plus b. 0 is b. So when I write my equation, y equals -2x, I don't write plus 0. That makes me look silly. Okay. So all of this would be on my lined paper. I skipped a few steps. Of course, feel free to do more steps. But on the front, you would write your final equation. Okay. Please don't try to shove all of your work in this teeny tiny spot. It makes my head want to kind of turn itself inside out. Okay, so this time you're going to do the slope of a line that's perpendicular. So, I don't want to ruin the fun here for you. And this gives kids a hard time. It says give the slope. You're not writing an equation, right? Okay, so you're just saying, for example, is there more on the back? Yeah. There's more on the B side. I don't want to steal your homework question. Give the slope. So in like number 16, of a line that's perpendicular, do the inverse of 3, which is negative, right? Positive turns negative. And the reciprocal of 3 is 1/3. Try number 17. Did you get 3 over 2? Yeah. So you're only finding the slope for these front view questions. Okay. As always, I'm going to be possessive, I guess, over your word problem because they're important and I like to do them with you. So I don't want to record it because I would like to talk through it with you. If you have questions, please do not at all hesitate to contact me. I wouldn't give you my email if I didn't mean it. So good luck with your work. I'm proud of you. Keep it up. See you in class. Bye.